composite functions. Our objective here for this video, we want to form composite functions. Okay, we know a couple of things that will come into play here. We want to remember, we know what a function is, a relation in which each component of the domain, each input value, each x value, corresponds to exactly one component of the range. And those components are called output values or y values. And we know that the domain of functions is restricted when fractions and or even roots are involved. We want to keep an eye out for those things. Okay, we saw in a previous video that we can create a new function by combining functions, usually 2, maybe 3, using addition, subtraction, multiplication, and division. Okay, we can also create a new function by doing what's called composing them. Now, this is a little more complicated than adding, subtracting, multiplying, or dividing. So I've tried to provide some more graphics, some more different variety of different ways to look at it, hoping that one of these will kind of stick in your head a little bit more. One of these 2 or 3 different ways will kind of stick in there and make sense to you. First off, what's a composite function? A composite function is a function made of other functions. And we usually have 2 other functions, where the output of one function is the input of the other function. So we're going to run our variable through a first function and get an output, and then run that output through a second function. So here's an example of that, and I've got a couple ways to look at it. We've got 2 functions, the function 2x plus 3 and the function x squared, and we combined them, and we did this one first, 2x plus 3. We got an answer, and then we squared it. That's 2 things that are happening here. This is an algebraic expression, and this is an exponent. So what does it look like in a picture here? X goes in. Okay, the input value goes in. We double the input. We add 3 to it. So x goes in as the input. We're going to double x, and we're going to add 3, and out comes 2x plus 3. And then this goes into the second function, which says take the input and square it. So this output of the first is the input of the second. Take this and square it, and out comes 2x plus 3 squared, which we of course could square in if we wanted to. Okay, so that's how a composite function works. Okay, another look at it and some more notation. Function composition is applying one function to the results of another. So we applied this function, the x squared function, to the result of this function, 2x plus 3. Okay? In other words, you apply the first function, in goes x, out comes the answer. You get an answer. You apply the answer to the second function, and you get the final answer. Okay? So in this case, we're going to go through f first, and then g. We put something in, the result of f is then sent through g to get a result, and it's written this way. Since f was the first function, it's kind of strange, it's on the back side. Okay, the second function is on the front side. This is a little clearer because this is the inside function, as you can see in the writing, and you do the inside function first. And then the g function is the outside function, outside. I wrote that kind of small. You do the outside function second. Looking at it this way, the f function is closest to the x, so it goes first. The g function is furthest away from the x, so it goes second. And this is just kind of a little open circle. It's kind of like a degree symbol, but dropped down and in between the two. Okay, one more way to look at it, and then we'll do we'll do a bit of composing. Okay, got some words and then another diagram. Lots of different possibilities here. It takes a little bit of thinking, figuring to figure this one out. So the composition of functions. The composition of the function f with g is denoted f little open circle g. In this case, it's f of g, okay? And it's defined by this equation, f little circle g of x, f of g of x. And that's written as f parenthesis g of x parenthesis. In this case, this is the inside function. This is the opposite of what it was on the previous page. Okay, g is closer to x, so the g function goes first, and then the result of the g function goes into the f function. The domain of the composite function, okay, is the set of all the x's such that x is in the domain of the inside function and that g of x is in the domain of the outside function, the one that is done second. Okay, a little tricky, but we'll work with it. Okay, here's another illustration of it right here. All right. Okay, we've got f of g of x, okay, which is the same thing. F of g of x is illustrated. The inside function, well, g is the inside function. Inside function is g. It's done first. So the input goes into the g function, okay? X has to be in that domain to work, and out comes the g of x. And then that's the new input, and that goes into the f function, and out comes the output for that. Okay? So let's take a look at some examples. Lots of it. It takes, again, let that, as my mother would say, let that percolate a little bit. I gave you 3 or 4 different ways of looking at it, and 1 or 2 of those should kind of make, should kind of make a bit more sense than the other ones, perhaps, and that's the way to think about it. So we're given 2 functions. F of x is 3x minus 4, and g of x is x squared minus 2x plus 6. Find f of g of x. Okay, well, we know f of g, that looks like the word fog, but I guess you don't want to draw that too large, of x is equal to f of g of x. This is the inside function. It goes first. So we put the x in, and out comes g of x, and that is x squared minus 2x plus 6. Okay, so we input x, it got squared, it got multiplied by 2, and then 6 got added to it, and that's what came out. That's fairly simple. Now we're going to use the f function. And I'm going to write this in a couple different ways. F of the input is equal to, well, here's the f function, 3 times the input minus 4. Okay, so the g of function is done. Now we need to apply that. This becomes the input of the f function. Okay, so I'll write it first as f of g of x. Okay, well, that means we're going to input g of x, whatever that is. This additional step might be superfluous to some of you. I just wrote it in there for extra clarity. Okay, we're inputting the g of x function into wherever it has. Whoops, I got it. I'm doing fine. So now let's continue. We know what g of x is. It's this. So 3 times the g of x function. And then we're going to subtract 4 from that. And now we just do our math. We do our simplifying. Minus 6x plus 18 minus 4. And this is 3x squared minus 6x plus 14. So f of g of x, okay, so we took x, we ran it first to the g function, and we got that. We then took that, and we ran that through the f function, and we got this, and this is f of g of x, right there. Okay, so let's go back, and I'm gonna copy on the next page here. I didn't have it up top, but we're gonna use those two functions some more. So let me go to the top of my paper, and let's remind ourselves that the f function is 3x minus 4, and the g function is x squared minus 2x plus 6, okay? Let's remind ourselves we don't have to flip pages this way. Now we're gonna do the f function first and then run that to the g function and see what the result is. You may be thinking, wasn't the result the same? And the answer is no. In fact, I think the result can be the same, but it almost never happens. I'm not exactly sure, but basically, no. The results are not the same. You know, switching the order of the functions will switch the composite function that's the result. So we know that g of f of x is equal to g of f of x. Okay, again, here is the inside function. We do that first. So f of x is equal to 3x minus 4. Done. X goes in, 3x minus 4 came out. Now we're going to take 3x minus 4 and we're going to input that into the g function. Well, the g function says take the input up here, square it, subtract 2 times the input, and then add 6. Okay, so g of f of x, and I'll skip the f of x part. Well, here's the input right here. So 3x minus 4 squared minus 2 times 3x minus 4 plus 6. Okay, again, the x went into the f function and it came out as 3x minus 4. 3x minus 4, the output, goes into the g function. It has to go in here, and it has to go in here, which is what I'm showing right down here. Now we just have math to do. Okay, well, all this, I'd already squared this, and this is going to be 9x squared minus 24x plus 16. Let's distribute the negative 2 minus 6x plus 8 plus 6. And let's combine like terms. 9x squared minus 30x plus 30, I believe, right? Plus 30, yep. So there's our composite function. And this function is the composite function g of f of x. Now again, I want to note, okay, example A was f of g of x, okay, and we did not get this. So these two things, you can't switch them. You can't do f first and then g. Do g first and then f and think they're the same. They're not. Again, I think there are some very rare examples where they are the same, but it's really rare, and I doubt we'll run across any of them. So we're not going to have the same composite function when we simply reverse the order in which we do the two functions we're working with. Okay, last but not least is an example. You can run a function through itself. Okay, so f of x. Take the f function, run it back through the f function and see what happens. Okay, we know this is f of x. So this is the inside function. Okay, so f of x is equal to 3x minus 4. X goes in, 3x minus 4 comes out. Now we're going to run this back through the f function. Okay, well, the f function says what you input in here, I'm going to multiply it by 3 and then subtract 4. Okay, so f of x. Okay, well, this is the input. We'll put 3x minus 4 and run that through the f function a second time. And we'll do the math. 9x minus 12 minus 4. So f of x is equal to 9x minus 16. So you can run a function back through itself. Okay, so this is, I'll just kind of call this, run a function back through itself. And, you know, that happens sometimes. You know, run the function and then rerun the function and see what comes up. So there you have it. Take your time. This takes some thinking, a little percolating, again, as my mother would say, a little thinking about it. And take care. Work on showing the steps as you work through it. It makes a lot of sense to be very careful as you're working down through and doing your math.